point. Before getting to this point, there have been a whole amount of lot of information and knowledge that we have acquired, understanding C program itself, even programming language generally, some concepts. We are learning a language and we need to really know the fundamentals, that what governs that language in order to make understanding and the usage of that language easier. So before coming to operators, talk about a lot of things like variables, constants, um, even the term identifiers. If I do a quick recap to the slide, even coming from this point, you know, we've talked about many things. As you can see, structure of the C program. you know, we've talked about the scanf, just a brief on that. There's something called scanf, something called printf. Okay, talk about variables and constants. We've talked about data types. Okay, the different type of all of this information are very, very, very necessary. Then we talk about the execution process of a C program, from how a source code is being what converted and translated to the machine code. Okay, all the processes involved, and we know that the C is a compiled program using a compiler. The GCC compiler, and we have been able to practicalize every operation that we can personally make use of. We can every of the operation we can personally apply to the GCC compiler. you know as regards the ALX project that we did previously, where we had to use some flags, that is some options on the compiler to give us some output at the different stages of compilation. And what are these stages of compilation? Four stages of compilation: with the preprocessor, the compile stage, the assembly stage, and then the linking stage. All these concepts are necessary. Then talk about constants. This was yesterday. I know majority actually might have missed it, but please, you can just go back to the video, or you just look for a very good resource that talks on this. This is necessary. Constants, and there are basically two type of constants in C: the numeric constants, character constants. And even the project that we that has been released, that is yet to get to the deadline, the variables if else. If you look at that project very well, it encompasses mostly on the character, even to be specific, character constants. That is telling you that you see character constants, they might be little, they might seem inferior. Or I'm just using this word to describe some things. They are not really inferior, they're very powerful. In fact, there are ways you can use character constants or as if you are using it like a number. And to be realistic, among one of the resources given, character constant is just understand it like another type of integer. Just understand character constant like another type of integer that has probably a lower range. Okay, because the maximum amount of data a character can what collect is 1 byte. Okay, so, and the range is from 0 to 255. That is for the unsigned. For the signed is from -127 to uh is it my plus 128. When you divide 255 by 2, you are going to have the range, the left and the right range. So we talked about all of these, and then integer constant categories: octal, decimal, hexadecimal. Octal 8, decimal 10, hexadecimal 16. All these things are necessary. Then all of these, the integer constant, is under the numeric constant. Okay, and the numeric constant is comprised of two, which is the integer constant and the floating point. Okay, under the what numeric constant. Then character constant, we have the single character and then the string character. And For the floating point, it has two categories: the float and doubles. Just understanding that these things exist, these things are, then trying to even practicalize how to use each of them. And we already described discussed before this time the declaration of what the each of the um, constants in C, how to declare them. And this is a character constant. Just all of this, and we don't want to dwell much on this. String constant is a sequence comprised of sequence of characters, okay, enclosed in double quote. That is the best, one of the best explanation of a string. What is a string? A sequence of characters that are what enclosed in double quotes, okay. Just like you have this string, as long as it is what in double quotes, it is what a string. You can see something tricky here. You have a single a, but it's enclosed in string, and at this point, this is telling you that this is a string. It is not a character. A character is individual with a single quote. So differentiating a single character from a string is by what? The quotes. Single quote indicates a single character, double quote indicates a string. And a string also, you can call it a list what of single characters. And this definition is imperative, that is very important as far as programming is concerned, because as far as C language is concerned, or generally programming language, string is like another array or an array, okay, an array of character, or we call it a list of character. And there are operations that are what performed on arrays, which can be performed on strings. And strings, since that each of the characters are individual separate entities, therefore they have position and location, okay, they have position on at every point that they are inside what inside that string. If I say Michael at this point, this is position one of Michael. And arrays or list in programming, the indexing, that is the counting, starts from zero. So this is part Michael, this M is at position zero, I is at position one, C is at position two, and H is at position three, and so on and so forth, like that, you know. So these are things that we talked about yesterday. And then also we briefly talked about that. Fine, if all of these things can be considered like a list, that means one of the operations that can be performed on a list is that we can loop through a list. What we say loop through, we can what? Perform repetitive actions on a list. If, for example, trying to compare a particular character with the other character. So in that sense, there must be a way for the C program to identify when it has gotten to the end of this string. So if you look at this, I'm even trying to look through my mouse. Okay, I've seen it. If you try to look at this, so what I'm trying to say is for the string that is being a list of character 1 0 1 2, okay, there's an operation that is performed on arrays that is what's possible on this string. And also if you are trying to move on the position of each, if you're trying to move in position on each character, position 0, position 1, position 2, there must be something to tell the machine, the computer, that it has gotten to the end of the string. Normally as human being, we know that Y is the end, is the last character here, but the computer is not actually even seeing Y as the last character. There is something that is applied to the end of the string to tell the computer that it has gotten to the end of the string, and this is what is called the sentinel character, or you call it the null character. And this is it here. So this /0, I mean / here 0, is used to determine the end of a string. So at this point, technically, humanly speaking, we can say that JOE as a string variable, okay, is actually um, is actually three elements there, but the computer is actually saying four. That is index 0, index 1, index 2, and then index 3 as the final or the last element. Just know that these things exist, or know that these things happen. And because when we get to string, at least the knowledge gap will be what closed a bit, and you can what quickly further on how to understand every operation that can be performed on string or arrays and all of that. So let's this was stuff that we talked about yesterday. Then This is how to declare constant in C. Okay, we have two ways of declaring constant, using the const keyword and using the define keyword. Okay, as we can see on the screen, I said this is not where we're going. Variables, I'm just doing a quick review. And this is our variables in C. Variables are used to hold values as we talk about it. And variables, what make variables unique is by what? The type of data they are holding. Okay, so if it is a number, if it is a string, if it is a character, if it is a float, if it is an array, it is what? By this data type, the type of data that what the variable is holding, that makes that variable unique. And also not only unique, that also makes the computer to know how much what space is going to reserve for that variable in memory, because C is an efficient programming language which what takes seriously how you use data. So for every data that you use in C, you must make sure that you know what you are doing in one. That is what C will always inculcate in you. And also to tell you that, okay, why are you using this data? Okay, why are you using an integer to store this variable? Okay, because I want to deal with numbers. Okay, even if you want to deal with numbers, how large is your number? So if your number is going to be very small, then I know that, okay, my, because I'm using small quantities of numbers, I'm going to use shorts. Okay, short int to what? Just to do little calculation. But if I know I'm going to use large numbers, probably integers, which what are not going to be having decimal places, then okay, I will know that I'm going to be using I will know that I'm going to be using long ints for what? For large storage of integers. And if I know that even these integers, this long int cannot be enough, then I'm okay. I'm going to be using long as what? As the type. Okay, as a type modifier. Okay, we talked about what is long int, short int, and all of that. I'm going to say, okay, because I'm dealing with large amount of integers, I'll be using a very I'm going to be using long to store it. You know, these are just what are concepts under variables that are necessary for us to understand. And also, when you are declaring variables in C, we have different ways of declaring variable. The way you declare variable in C, it has to be what? It has to, you have to take note of the type. That is, you have to what, specify the data type of that variable that you want to you are declaring,
Please
and
come.
also you want to specify the name of the variable, because what makes a variable is because it has a name. Aside the fact that what it is being stored in computer memory, it must have a name in order for us to identify it. And that is why you call variables a kind of identifier, because anything that you can identify anything with is called an identifier, which is an example is a variable. So declaring variable, you must have the data type and you must have the variable name. Okay, and then you must what have it must, and that variable of course must have a value in order for that variable to be valid. So ways of declaring variable: you can declare variable and initialize it immediately, which is this first one here. Data type, variable name, and set it to a value. That is a variable that has been initialized and a variable that has been declared and initialized at the same time. And this one, you can say, you can just decide to what? Declare the variable. You can just keep it down that, okay, I want to you declare this variable called bag, because I'm going to use this bag to store my books and my clothes later. So I can say I'm just declaring this variable, but I'm not giving it any value. Just like you buying a bag and you're not putting anything inside yet. Okay. And these are other ways and acceptable ways of declaring variable in C. You can declare a single variable without initializing it and then initialize it later. You can declare this is for an integer, the same pattern for what? A character variable. You declare it first and then you what? Assign a value to it later. You can decide to declare a variable and initialize it at the same time simultaneously. So an integer variable declared and initialized simultaneously at the same time. This is a float variable, the same example. And you can even decide to what? Declare more than one variable with the same type on the same line. When you are declaring more than one variable at the same time, they must be of the same type. You cannot say you are declaring int a comma float b. No, error will occur. So if you are declaring this, I'm saying I want to declare three integer variables a, b, c on at the same time, and I'm not even initializing them. That I'm not even giving them a value here. So at number 6 here, you can decide to even what declare them at the same time and even give them value at the same time. This is possible, and this possibility is being what illustrated on a character variable car hey, and this same can apply for an integer variable or whatever type of variable. You can just know that these things are possible. And then we talk about keywords, which are reserved words in C that have special meaning. These words are necessary for the general implementation of programming logic, and they are what they are necessary for us to do all our programming. They are just like the the verbs and the part of speech of a programming language. I think that is the best way to explain it. A verb is a part of speech, right? So they are not like a part of speech to speak a language, a programming language. So we have all of them: int, float, break, go to. There are 32 keywords actually in C. Among all of them is this, and there are more. So data types, okay, data types are needed for holding different types of value in the computer memory, as we have said over and over again. Each data type, they must have a they have a specific amount of space, and that is the reason why C is what very very strict with data type, because it must know why you are using that data so that it can what do its own calculation. C is a is a manager. C language is a good manager that knows how to manage something. So you, as a project manager that C language is, you must what be specific and explicit with everything that you are doing. So data type, they have specific amount of space they store in memory. They occupy in memory. If it is an int, it has a space that it store, and even if it is an int, it's if the variation of that int matters to know the type of data, I mean space, it is going to store in memory. Another thing here is that for every data, okay, for every data or for each data, its equivalent data type is needed to be stored in memory. What does this mean? For every type of data, example of the types of data that we always have, you can have a character, okay, you can have a string, you can have an integer, you can have a floating point data, or you can have an array, okay, you can have a union and all of that. So for every type that you are storing, there is an equivalent amount of space that the computer will acquire, allocate for them in memory. Now, the amount of space occupied by a data type, okay, or variable in memory is determined by the size of that data type, okay, as I have said this before already. So, and the size of a particular data type is dependent, okay, take this as something that you can hold. The size of a particular data type or the amount of space a particular data type will occupy in memory is dependent on the type or the kind of modifier used. Okay, we have modifiers, we have modifiers in C and we have qualifiers in C. In a minute, you are going to see what we are talking about. So, okay, now there are three categories of data types in C. You know, all these things, the way this stuff are structured will give in-depth understanding about why you need to why it is always good to just get a structured understanding on how to learn a particular language. Okay, so understand that there are basically three types of data types in C will give you a head start on treading the right path. So we have number one, the primary data types, or you call them the built-in data types. Example of primary data types, which we have been speaking over and over: numbers, okay, characters, and then this one is like a new thing for some person: void. And it might not be new, but it's a kind of data type because you'd have seen where they are doing int main, okay, where we in our programming in our projects, you'd have seen where they wrote int main void inside, in between the parentheses of the main function. It means it is a data type that, which means empty. So it's a special primary data type. Okay, so Among the three categories of data type, we have talked about the primary data types, which involve numbers, characters, and void. And don't forget numbers, we've talked about it under constant. There are two types. It can either be an integer or, so we don't want to waste time. Derived data type as the second category, an example is the array structures, unions and pointers, and then user-defined data types, type def and enum. All these things are concepts that they have deeper meanings and operations performed on them. So it is good that you know that they exist, and so that when you get to what operating with them, we can be able to what go smoothly. Now, what the next thing what we that we have here is qualifiers and modifiers in C. This is just to understand that I was talking about something that the size that a particular the amount of space, okay, that a particular data type is going to occupy in memory is dependent on its qualifier and the kind of qualifier attached to it, or the kind of modifier attached to it. So what do we mean by qualifier or modifier? What is qualifier? Qualifiers are keywords, okay, applied. They are keywords that are applied to the data types in order to change its meaning or property. Excuse me. So qualifiers are what? Keywords applied to the data types, and they have what? They change the meaning of that data type. What do we mean? For example, the amount of memory space needed to be allocated for a variable is derived by what? By the modifiers applied or attached to it. If that's what data type is a short, for example, short int, long int, or sign int, unsigned int, long int, all these as it is, they have the amount of specified space they occupy in memory. And before that, if you look at that, everything you need to know about C, that resource that was given by ALX, where you see different things at the same time. You can, if you see the let me just get code there. If you look at this aspect, you could see data type. You could see this chart or this table indicating what the different data type, and then it's giving some, you can see some terms here. You see storage size, and you are seeing what 1 byte, and you are seeing what another thing, you are seeing value range, and you are seeing what minus 1282, blah blah blah, like this. All this that you see here, from here first, the type that you see here, from you are seeing type short, long, and all of this, they are the what? They are modifiers down to what? This type, down to the range that is here. They are what? They are the modifiers. And this man here is what determines what will be the output or the value of the storage size. Whatever it is here, the type that is here, there's a standard value for it, and that is what will determine the type here. So this chart is something that is needed to for us to go through, and also what to make that chart more interesting and understandable is this, understanding that those things are called modifiers. Okay, and what do? They change the meaning or properties of that data type. Okay, and also what do we mean by that? They change the meaning of properties in the sense that they have an effect on the amount of space, okay, that's what that variable is going to be, what is going to occupy in the computer memory, or the amount of space that that variable is going to be given in the computer memory. We are still saying the same thing. So now modifiers are prefixed with what? Basic data types to modify, increase or decrease the amount of storage space that we have said. It just like the same thing we said above. Now, for example, storage space for int data type is 4 bytes for 32-bit processors. We can increase the range by using long int, okay, which is what 8 bytes. We can decrease the what range by using short int. This is just like an example to give you an overview of what is we are talking about here. Now, to now make it more deeper, there are 5 modifiers available in C language. And now, what are they? the short, long, 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 signed and unsigned. And each of these are what they have group. Okay, short, long, long, long are under the size modifier. What do we mean by size? That is the storage size, uh, the amount of size, or the its size in bytes, okay, or the amount of space it's going to what take or occupy in the memory. You can see this. This is char. Now you could not see anything like sign or unsigned on a normal day. Just know that when the sign is not prefixed, maybe when there is no prefix like signed or unsigned on a particular data type, it is automatically signed. When the prefix is not what given, look at this resource. I think I saw that. Okay, look at this. He said the commonest. Mm-mm. Look at this example on chart. The chart variable can be made signed or unsigned as you prefer. But in the absence of the indication, okay, I think this is the right word to talk about. In the absence of indication of a particular, they are probably signed or unsigned to the what? To that variable. Even is saying that okay, they are allocated the efficient sign and type. Okay, that is the compiler will allocate the efficient type for that um for that data type. But aside that, just know that if the sign is not specified, it is signed already. If there's no indication, this is a sign short. If uh, if it is not indicated on long, it is signed long automatically. And if it is unsigned, of course, it will be what? It will be indicated. So basically, it is like unsigned is the new thing here, which we need to understand its property, because unsigned will what? Will give the range. And also to sign too is necessary, okay, but it applies to all of these above. So you can say 1, 2, 3, 4, they are still under the signed, okay, under the signed what? Uh, under the signed. I want to use something. So all this man here, they are what? They are signed what? The assigned type. Okay, so and also a sign type, it has its own what? Range. It has its own range. And unsigned too, it has its own range. So these are the things that makes them special. The last one, type modifiers, C type modifiers. Okay, C types are keywords just like the qualifiers to apply to a type to modify its properties. Okay, there are two types of the C type. We have the const, the normal const used for declaring a constant, and then this volatile is like a new feature in the C program. Okay, so let's move on. This is the chart that we've seen as much as possible, and let's move it to today. So what do we have for today? We want to talk about operators before we now move into solving the problem, because that was about how many minutes I used for that? I think I used like 30 minutes or 20 something minutes to explain all that, to do that revision. So before coming here, part of the thing that will make this understanding better is this slide here. So operators are symbols, okay, which tells the computer what kind of mathematical or what kind of logical or what kind of relational operation it should perform on variables. Okay, the statement is not complete. So what kind of all of this operation, mathematical operation, logical operation, or relational operation, it should perform on a set of given or a set of given what? Variables or expression. Okay, so now with operators, okay, when we are using operators, operands, and what are operands? The values or variables on which the operation is going to be performed, okay, or are performed upon. Okay, operands are the variables which operation are performed upon. Okay, so with operators, operands form a what? They form a sequence of expression to perform a particular task. So, what is an expression? A sequence of given operators and operands. So, expression is a sequence or set of given operators or operands, and expression must always give an output. And there is always a difference between an expression and a statement. So, example of expression, we have expression of a equals 5 plus 5. Now, what are the operands here? A is an operand, is a variable, is an operand. Um, 5 is an operand, and this 5 too is an operand. And what are the operators happening here? We have the arithmetic operator, arithmetic plus, and then we have what the assignment operator. So we have the plus operator, and then we have the what? Assignment operator. And these are the operands upon which they will what? These operators are going to have an effect upon. Okay. We have another expression here, a less than or equals to 5. So this is an operand, this is an operand, and this what? These guys are the operator. This is a less than operator, and this is an what? And in this case, an equal to operator. When you use these two together, it's called less than or equal to. You know this, of course. And then this man might look new. This is what? An increment operator. Uh, these two increment operator. Well, we will see what this will be broken down, and we'll understand it. So this is the increment operator. This is the what? The operand A, and whatever result happening to this man will affect A. Just like you can see, A equals, this is the same thing as saying A equals A plus 1. So operator, they perform some thing, we can call it like they are known for affectation. Okay, that is having an effect on given set of operands. Now, categories of operators or types of operator. There are three categories. There are three basic categories of operators in C, and this is necessary as to give foundation. Okay, now we have the unary operator. And what does this mean? An operator that consists of only one operand to perform an operation. Okay, then we have what? The binary operator. And this operator what consists of two operands to perform an operation. And then we have what? The ternary operator. This one consists of three expressions, what? With three operands. Is not even operand, because operand is what the effect of the operation is going to affect. So ternary operator consists of majorly three expressions, and the operands could be more than one. Okay, it could be more than one. So to perform an action, now let's explain the explicit. Now, unary operators, these are operators that requires only one operand to execute actions. Okay, now uh, part of the type of the unary operator, where's my mouse? Okay, part of the type of the unary operator, number one, is the unary minus and the unary addition. And these are what? The minus and plus. Now, these operators are used to either increment, that is unary of addition, e.g. a plus plus, or decrement, in this case using unary minus, example b minus minus, the value of a given variable. Okay, I don't know, we've been having this session for some time. Probably I don't know how we are doing. Everybody have their own learning style. Okay, so I just want to be like, I believe some we could have been like especially something that might be new to us. Part of the way of making learning effective is making sure, probably having a note to just jot down some things, because these are a lot of terms and concepts. So part of the way to make concepts easier for us to understand is understanding the name it bears. From the name it bears, you can now search through and then try to define its meaning. Okay, that is just by the way. So types of the unary operators, we have the unary minus and the unary addition. Okay, what does this mean? These are used to perform arithmetic, okay, on, just take it that way, on the operands. So part of the arithmetic that can happen is increment or decrement. So now these increments can be either prefix increment or decrement, and prefix means they can increase, okay, they can increase a particular variable, or they can decrease a particular variable immediately before it is being used. We will get, there's an explanation on this. And it can also be either postfix or or after increment or decrement. Postfix means after. So taking a deep breath and then reflecting quickly, unary minus, unary addition, minus and plus. Unary operator generally execute actions or perform operation on just single operand, one operand, a single variable. Unary minus and unary addition. Okay, unary minus is used for performing decrement operation. Unary addition is used for performing increment, okay, operation. And this increment or decrement, okay, this increment or decrement can either be prefix before or postfix after. And the indication of a prefix increment is plus plus a in this case, that is prefix increment, or prefix decrement minus minus d. Postfix increment and decrement example is, that is the sign coming after, in front, okay, the sign coming in front of the variable or the operand, that is postfix. And this is postfix increment, postfix increment. It can also have c minus minus as postfix decrement. Okay, so this part, this increment and decrement, sometimes it is usually confusing for some persons, but understanding this basic thing can help. So okay, so now the second one is what? The logical not. This operator inverts what? The boolean value. And what is the what are boolean values? Boolean value can either be true or false. Okay, boolean is a logical entity, or it talks about logic, such that the return value is either true or false. So when you now talk about logical not inverts true or false, invert boolean value, that is, which can be either true or false. That is, if the present value is true, when you apply logical not, the value will be what? Will become false. And if the present or current value is false, when you invert logical not, when you apply logical not on that variable, the result becomes true. So it's just like opposite, words and opposite. Okay, that's, you can use it like that. For example, this is an example. The expression inside this bracket is will be what? Will be executed first. And whatever result that is there, the logical not will what? Invert it, will give the opposite. So if you say a greater than b, Now, this does not really make sense because we don't know what is the value of A. So let's say A is 3 and let's say B is what? 4. So if we now look at it, is A greater than B? Is 3 greater than 4? Of course, it is not. And this word will return false. Okay? So false is really actually 0 in the computer memory or the computer language. Anything false is 0, and anything true is 1, or anything non-zero. Anything that is not 0 is what? True. Okay, anything that is 0 is false. So this expression will return false, which is 0, and applying what? The logical not on it will turn it to what? 1, which is become what? True. Okay, now the other unary operator that we have is, we are going to practicalize the use of these operators. Okay, we have the address of or ampersand operator. Now the address of operator is used, this is the symbol and, example you can say and A. Okay, so the ampersand operator is used for retrieving the address of a particular variable in the computer memory. One of the things we said, C language, it is very, very uh, concerned about how you use your variables, okay, and how you use your different data type. So we already say that every variable, they have a location, they have a place, they have an address in the computer memory. So that is one of the things about C. So as a result of that, there is an operator that is used to get the address of a particular variable in memory. Okay, and that variable is that operator is called the ampersand operator, or you call it address of operator. And this is it. And how do we use it? You use it with the printf. We say printf with this format specifier for printing is what? %p for printing the address of what? The variable A. So whatever is the address of A, %p will return the value. Let's do some check quickly. Programs quickly. quickly. Oh, sorry. So if we come here and I quickly say, okay, I'm increasing the screen so you can see, and I quickly say printf. Okay, I declare the variable int a. I give it value of int a equals 22, and I even declare another one int b. Let's say car b, and I didn't give this one a value. And I want to print the address as it is, that I declare it already, even without initializing. It has been given an address in the computer memory. Okay, so if I say printf and I use the format specifier, I use %p for what? For printing address of an operator. And I say %p. No, before that, I say something. I say address of A in memory. Okay, in memory is, and I do it like this, and I probably return a new line because we have more than one printf to use. The same thing applies to here. So I said like this, and now for me to locate A, I have referenced %p to get the address of whatever variable I pass inside here. The next thing for me to do is what? I'm going to use alongside ampersand the variable itself. So %p is not actually the one getting the address. Sorry, %p is just what? The format specifier for printing an address, because the address itself will be in hexadecimal format. It will be a mixture of not integers and then letters. So as a result of that, the percent %p is the best format specifier for printing. So when we now run this man like this, okay, let's do that for printf address of b in memory, okay, is, and I say percent %p for all new line, percent %p is for and b. Okay, so it's with what? Giving the address of a, this variable a, which is an integer, and then give me the address of variable b, which is an integer. So let's run it. And you say hello world, address of a in memory is, look at, you can see is a mixture of now letters, so it's an hexadecimal, and then address of b in memory, and you can see. So this is necessary and very very important by the time we get to pointers, because when we get to pointers, before we get to pointers and all some tricky thing about C that makes C look as if it's very very hard, because it is when you believe that something is hard that it will be hard. That is one of my own beliefs. So just know that there is a operator called ampersand for getting or retrieving the address of a particular variable and using this format specifier %p. Okay, so size of operator, we have used this one before, of course, is used to determine the size of a particular data type based on a particular machine. Okay, and it is used this way: printf using this format specifier %lu. This means long unsigned. You can use %lu if you're actually trying to look for the format specifier of an unsigned integer, or you can use zu. Let's quickly test these two. Let's say we want to do printf, and we want to say address size of int a, okay, in memory. Okay, so we can say now this guy is actually signed. So if I use %d, this is for signed int. Normally, we have done our project and we passed it, and everybody use, some persons use lu and some persons use zu, and even the fact there's something called du too. Okay, is it du? Okay, there's no du. Okay, lu, zu, and there's another one here called ordinary u. So we didn't, none of this was explored. Okay, everybody used whatever they use, and the checker passed them. That is why if you read the requirement very well, you could see somewhere they said errors are allowed, because obviously the GCC compiler will specify an error based on what you use if you did not specify that it is an unsigned or signed. So this guy is actually signed. So if I say %d, it will give me the value. So how do we print the size of an integer, a signed integer? I say size of, and I what is the integer? I pass it inside a, because I have given it value already. If normally I just want to print plainly, I can just pass int. So this will work too. So just try to find the size of a signed int. So let's test it too. Let me say this. Look at size of int a, obviously is 4, but if I put a, because I'm just testing for a now, before was int a, so now this is int a now, and the size is what? 4. So now let's check for size of b. It will be 1 byte. A car will always return 1 byte. So look at it. So we are using this d or whatever is as a format specifier. It's always good that we try to view format specifier too, so that printf will become easier for us to use. Okay, so size of operator, and that is the end of what? The list of the unary operators. So unary minus and unary addition, which can be used for increment and decrement, logical nots, okay, and address of operator, unary size of operator, unary address of operator, unary logical not operator, unary minus or unary addition or plus operator. Okay, So these are the four unary operator. Now, quickly, I want to dive into this increment and decrement operator because we just said that we didn't specify. So now, quickly, the increment and decrement operators are special operators under the category of unary operator, okay, which performs mainly arithmetic operations on a single operand, okay. So the general syntax of the increment and decrement operator, okay, for the unary increment, this is just how you use it, plus plus, okay. I actually didn't complete this statement. I wanted to put something there. So, but this, let's talk about unary increment now. And this symbol is what? Plus plus. The unary increment increases the size, okay? Increases the size, increases the value of a given variable by one, okay? So unary increment increases the value of a given variable by one. Note, the effect of the increase, it now depends on the condition, whether it is a postfix increment or prefix increment. So what do we mean? Let's test it. Let's see what it means. For example, we want to test for unary increment and unary decrement. Let me just leave this. So let's say increments and decrements. So let's say we have, now let us apply it on this variable, okay. Now this man has a value, so of course it is the one that will be valid to apply on upon. This guy does not have a value yet, but let's give it a value. Can b equals, character. So c, let's give it no let's give it a number. Let's give it 10, okay. That is one of the power of character variable. I said it, remember we said it is just another type of integer. So we can say printf post increment of what? A. And then we'll do what? Percent B, new line, and then we can come and do and say A plus plus. Okay? Because that's what we want to print. Now this time around, let's now say printf the new value of A. Okay. Now, no, let me make, I want to reference something. Let's say output one, value of A. Okay, so now let's reference A at this time. After we are what? We have applied postfix increment. Okay, so postfix or a post increment is it goes. It's just the understanding that matters. So now let's now do again. Printf output 2, value of A percent B on a new line. Okay, so at this point, what should be our response, our value, output. Now look at this expected output of A, okay, is what? Value of A plus 1. That is what everything about increment is about, to move by one step or add increase by one, okay. So now this is what we have here, okay. Now let's run it. We have what? Incremented the value of A, right? I think this should be better. I don't know if it's better there. So we incremented the value of A, right? What is the initial value of A? 22. And we have added what? The type of increment we added what? Postfix increment. So now let's run the code. and let's see the output. Now look at postfix increment. Okay, sorry, let me do something. Print f. I'm gonna clear this. I don't want to see it. So print f. I'm going to here. Print f initial value of a. Okay, %d new line, and I say comma a. Okay, now let's see. Look at this initial value of a 22. Now postfix increment of a, that is a plus plus, it is still what? 22. Now look at now output value, output one value of a. Now a is now what? 23 after what? The increment has been applied to it. Look at now output 2 value of a 23. So postfix increment is now what? Is it will what? It will apply it will increase the value of a variable. It will increase it by 1 after it has been what? Used. Now let me do something. Let me clear this initial value of a, and let's see what will be the result. You know, we had 22, 22, 23, 23. Let's see. Can you see? So at the point that the postfix was what? Added to a was still 22. But when we printed it again,